guys, this is Ms. Miner, and this is 5D. 5D, lesson 5D. Oh, let's take a look at our goals here really quick before we start off. Okay, our goals today, we want to be able to understand what a system of equations is and how it can be used to compare two sets of data. And so you can see I've written in here, a system of equations is more than one equation. So you can kind of highlight that. A system of equations is more than one equation. And we can use this idea of comparing two equations. And we've actually done this before. Remember back in the olden days when we were talking about was buying the big mug worth it, right? We were comparing two equations and we were trying to solve to find out where those two equations were the same. Where were they the same? So that we could decide if it was a good deal to buy the big mug at the movie theater or not. Well, we're going to just talk about another way that we can do that same thing. Today, we're going to use our graphing in order to be able to compare two different sets of data, two equations, and find out where they're the same. So that's what we're going to be doing today. All right, so let me make this big. Okay, so a system of equations, remember, is just more than one equation. This word systems, a system is just working together, right? And so this is more than one equation. We're going to take a look at more than one equation and compare them. And so this is what we're looking for. And we can kind of use our arms as our lines in order to decide, what we're looking for. And these are the results that we're going to get in a system. If I have two lines, right, and they never cross each other, so if my arms are like straight next to each other, they're parallel to each other, then there's no place where those lines cross. And anytime a line crosses with another line, that point where they cross, that is where those two lines are equal to each other. And so if my lines never cross, I'm going to get an answer like no solution. They don't cross, so they're never equal to each other. If I have one place where the lines are crossing, and with straight lines, we're only going to get one place where the lines cross. I'm going to have one point, and I'm going to write it as an ordered pair, and that's going to be my solution. X is this place, Y is this place, that's where they're the same. And so I have an X and a Y value where those two lines are the same. And when I'm dealing with straight lines, I'm only going to get one point where those two lines cross. There's only going to be one place. Later on, when you're in 9th grade and 10th grade, you'll work with some curves and circles and things like that. So you might have more than one place where those things cross. But for 8th grade math and in this class, we're going to deal with straight lines. And so straight lines really are only going to be crossing in one place. So we'll get just one solution. And then lastly, we might get infinite solutions. If the lines are laying right on top of each other, kind of like these arms are illustrating, then I'm going to get infinitely many solutions, because if the two lines are laying right on top of each other, then every point is in common with the other line. And so all of the points are going to be, trying to think of my words here. All of the points are going to be the same. And so I will have infinitely many solutions. There's infinitely many places where those two lines will be the same. So let's kind of see how that works. Okay, we're going to use this graph right here to illustrate one, none, or infinite solutions. So we're going to look at a couple of systems of equations. I'm going to highlight some lines for you, and you're going to decide if those have one, none, or infinite solutions. Okay, so number one, let's take a look at number one, the line y equals negative x minus 3. Y equals negative x minus 3 is this line right here. And the line y equals x minus 1, this line right here on my graph. So taking a look at those two, how many places do those two lines have in common? Where are they equal to each other? And hopefully you said only one place, because these two lines cross right here. So this has a one solution. These are the same at this spot. And so this is where x is -1, right? X is -1 and y is 2. So my answer will be x is -1. Y is, oh, I'm sorry, -2. Y is -2 right there because it's down from the center. Okay, so now there is my solution. Well, what does that mean? Well, it means that right here at this point where those two lines cross, both of those equations are true statements. When x is -1 and y is -2, this is going to be true and that is going to be true at the same time. So, and the truth is that is the only place on the graph, the only point on the graph where both of those equations will be true at the same time. Let's prove it to ourselves really quickly. So I'm going to split screen this and I'm just going to put in a blank page here. And we said that right here when x is -1 and y is -2, it will make both of these equations true. So I'm going to put my equations up here. Y equals -x minus 3. There's my first equation. And then, actually, let's do this. Let me just slide this over. And then my second equation was y equals x minus 1. Okay. So what we're going to do now is we're going to substitute in our x and our y value and solve this equation and see what we get. So the first thing I'm going to do is I'm going to substitute in a -2 for y because that was my y value up here. And I'm going to substitute in for x a -1. And then I'm going to solve. So negative times a negative is going to make that positive, and I'm going to get 1 minus 3 is equal to 2, and so 2 is equal to 2. There's my true statement. Next, I'm going to substitute into this equation the same numbers. Y was a -2, x is a -1, and I'm going to solve. -2 equals -1 minus 1, so -2 equals -2. Here's my true statement. So both of those, using this point right here, both of those equations are true. Well, what if we used a different point from the line, right? Look, what if we use this point? What's happening there? Well, if I use a different point from my graph, then these statements aren't going to be true. So let's use this other point, this red point now. That is where x is 3 and y is +2 this time. If I put that value into my equations, so I put my x and y values into those equations and solve. I get 2 equals -3 minus 3. So 2 is equal to -6. That is a false statement. That is not true. This one over here comes out true, but they're not both true at the same time. And that should make sense because that point was on that line. So that made that one equation true, but it didn't work for my other line over here, right? So you can see what happens if I choose a different point from the graph. They're not both going to be true at the same time. The only place where both of these equations are true is right there where they cross. And so that's what we're looking for. And that's the one place where these two equations are equal to each other. So that's what we're looking for. And remember back when we were talking about the big mug, right? This would be the place, right, where both of those equations are the same. X would be -1, y would be -2. Okay, so now remember we talked about that the y value mattered. And when we were doing this before, we were only getting the x value, right? And we said, oh, well, the y value does matter. And so now we have a method that we can use to be able to find the y value where they're equal as well. Okay, next class period, we're going to introduce some word problems in that deal with system of equations so you can kind of start to see what those values are telling us. These are a little bit abstract right now, but in 5E, we'll do some story problems, some real world context, so we can kind of see, oh, what are these values where they're the same? What are those talking about? And we'll kind of give some context to those numbers. Okay, so let's just practice finding the place where they're the same for this homework, and then next time we'll introduce some context in to kind of talk about what those numbers are representing exactly. Okay, so now we're going to take a look at some of these other lines, and you can see we don't have to go through and like prove, right, that both of these are true. What we're really interested in is finding out, do they have one solution, no solution, or infinitely many solutions? But I wanted you to see and illustrate to you guys what was happening with this place where both of those equations are true. And what's essentially happening is, oh my goodness, is I need to lock that in place so it's not sliding around everywhere. It's making both of those equations true at the same time. Okay, so I'm going to come back over to here and make it big again so that we can really see what we're doing. And then let's go ahead and highlight. I'm going to just really quickly slide up here and lock this in place so that it can't slide around on me anymore. Okay. All right, so let's take a look at our graph again, and this time we're going to highlight two different lines. We're going to highlight 2x plus 2y equals -6, which is this line right here. There we go. And then we're going to highlight this line, y equals -x minus 3, and that is this line right here. Okay, what just happened? Well, they're both the same line, right? They're covering every single point the same. They're kind of like laying on top of each other. And so my answer here would be infinitely many solutions because they have all of their points in common. This is the same, that's the same, this one's the same. All of these points are the same on the line, and so every point will make both of those equations true. And we could go back and pick a point and solve for it, but I'm not going to take up that kind of time. If you would like to prove that it's true, pick a point from the line, right? Pick a good point on the line, go in, put in the x value here for x, put in the y value for y, and solve to prove to yourself that both of those are true. And any point on those lines would be true. It would make both of those statements true. Okay, number 3, y equals -x minus 3. That is this line right here. Again, and then y equals 2x plus 2y equals 4, this line here. What's happening with those? Well, those two lines are parallel lines, so they'll never cross. So this one would be no solution. There's never going to be a place where those two lines are the same. And then last, we're going to look at this last line, 2x plus 2y equals -6. Again, here's our good friend line. And then 3x plus y equals 3. Okay, well, those lines are going to cross. And if I kind of look at those lines, they're crossing right here at this good point down at the bottom. And so my solution is x is 3, y is, looks like about -6 there. It's just covered up by my speech bubble here. And so the solution would be x is 3, y is -6. And we could take that point, we could plug that point into our equations here for x and y and prove that those are two true statements. If you'd like, you're welcome to pause the video and put in your x and y values and prove that those two statements are true at that point. Okay, let's move on. Oh, I need to reset my page here. I've got a little Let's reset this page so we can take a look at this again. All right. We're just going to skip ahead. We're going to look at a couple of these points. I want to make sure I don't make your video too super long. So we're just going to look at the last three graphs here. This is like what will be on your homework today. You're going to be graphing the lines and then deciding, do they have one solution, no solution, or infinite solutions? So taking a look at number 8 here, let's go ahead and graph it. I start at my beginning point here where y is equal to 6. And so you can see that the middle of this graph is kind of right here. This is where 0, 0 is located. It's kind of, this graph has been slid down just a little bit. And so this is, this will be 0. And so I want to go where y is 6. So I'm going to go up 6 from there. 1, 2, 3, 4, 5, 6. That's my beginning point. And then I'm going to use this as my slope. My rise will be -2. My run will be 1. So I'm going to go down 2 and over 1. And for system of equations, you're going to want to get quite a few points on your graph so that you can be very accurate in your graphing, because you want to know where these lines are going to cross each other. And if you're not being accurate in your graphing, it's going to be really hard to tell where your lines are crossing each other. So make sure when you're graphing, you're getting those lines crossing right through those points and being fairly accurate with them. Okay, let's go ahead and graph our second line then. And our second line, we're going to start where y is equal to 2. And then I'm going to use my slope as a rise and a run in order to graph my line. And I'll make this one be blue now. Okay. I better get a little bit more accurate here. There we go. Okay, so I can see that these two lines are crossing right here at this point. And so I've got to know what that point is, right? And so I look at my graph and I say, okay, x right there is a 1. So x is going to be +1, and the y value right here is 4. And that is the point where those two lines are the same. This is a one solution where x is 1 and y is 4. Okay, let's take a look at number 7 then. Let's graph that one. And I'm going to start graphing this one right here where y is equal to 3. So I start in the middle of my graph. I go up 3, put my first point there. Then my slope is a fraction. And so my top number is going to be my rise, and my bottom number in my fraction is going to be my run. And so I'm going to rise 2 and run 3. And I can switch directions. I just go in the opposite direction that I was going. I was rising 2 and to the right 3. So this time I'm going to go down 2 and to the left 3. And then I can get some more points and be more accurate with my line. Oh, you guys, I thought I locked that in place. Oh, that was the other one, huh? Let's lock this one in place too here really quick so I'm not like sliding that all around the whole time. Okay, now I can put my line in there. I got to get my finger going. There we go. Now I can put my line in there. That's what I want. Okay, so now let's go ahead and draw our next line here. I'm going to start at -2, and so I'm going to be down 2 from the center. And then again, here's my rise and my run. So I'm going to rise 2 and run 3. And it looks like that's all that's going to fit on my graph. So let's go ahead and graph that. Okay, let's take a look at these lines. What's happening here? These are parallel lines. And here's a tip, right? Parallel lines usually have the same slope. Usually always have the same slope, right? They have the same slope. They have different y-intercepts. And so that's a good bit of knowledge for graphing lines. If they have the same slope, chances are they're parallel lines. And so these are going to be no solution. They never cross. And so they're never going to be the same. Okay, last one. Well, if I'm looking at this, Ms. Miner just told me that if they have the same slope, they're parallel lines, right? Hopefully you said no, because these two have the same y-intercept. And so if I graph these two, let's do this really quick. I'm going to graph, start right here at positive 2, and then use my slope and graph my line in there. And this one is a line that goes like that. My next line is a line that's going to go on the exact same place, right? My slope and my y-intercept are the same. And so these two lines are just right on top of each other. So these two lines are infinitely many solutions. They have the same slope, they have the same y-intercept, so they are identical lines. And that means that every point they have in common, they will have infinitely many solutions. So there's some illustrations of what we're going to do on our homework assignment today. If you are still working on figuring out graphing, right, this is a skill that we need to do today's assignment, is graphing these lines. And so that'll be something you want to make sure, if you're still working on getting your graphing of your slope-intercept equations down, make sure you're talking to me or Mrs. Zeider and getting some help and practice doing that. And then if you have any questions, make sure you email us or join us for our Google Meets. Thanks, guys.